what is associative property, identity property, and also inverse property with respect of addition and also with respect of multiplication. Okay. With respect of multiplication means we'll have the multiplicative inverse and also multiplicative identity. And also one more property will be there, that is the commutative property. And the fourth one, another property is the distributive property. So distributive property over addition will be there. So that is very important. So whenever any set, so if you know the concept of the set there, any set that is a natural number, usually for the standard notation of the numbers, we have no natural numbers or integers or complex numbers or real numbers or rational numbers. For those all numbers, we'll have the standard notation of the set. Okay. So those sets, if they satisfy some of these properties, then we call them as a group. Okay. Whenever any one of the property is not satisfied by the set, then we call it is whatever the set is there, it is not a group. Okay. So abelian group is there, cyclic group is there, like the different topics are there. So in this compulsory, each and every definition, even in the examination, definition will be asked. That is, what is a group, what is a semi-group, what is a subgroup, and also what is normal subgroup will be there, cyclic group is there, abelian group is there. Like the different definitions will be there. On regarding of these definitions, you will be given the theorem. Okay. So if a subgroup is there, means show that the given any set of is a subgroup. So first definition will be asked. So definition will be for 2 marks if it is a 5 marks question. So if it is a 10 marks question, means you may give when 3 marks, 3 for the definition and 7 marks will be given for the theorem. Okay. So that concept you have in second unit. So if you see the second unit, you have the definition of the group is there and which set of numbers, that is either natural or integers or real or rational, irrational, complex numbers. From these, which sets are forming the group. So that concept we have. So in unit 2, almost you have properties of the group will be there. So after that, some example problems are also there. This is about the second unit we have. After completion of the second unit, even in this some theorems are there and also some problems are there. If we go to the third unit is about the subgroup is there. So subgroups and also cyclic groups. Okay. Subgroup definition will be there. So if you know the concept of the subset, almost it will be similar to the subset definition, whatever you have will be studying. Subgroup will be there and also you will have the cyclic group. This cyclic group concept is very important. So on this compulsory 1 5 marks question and also 1 10 marks question you will get in the examination. So in third unit, you have the definition of what is subgroup. And on subgroup, you have some theorems are there, that is 3.3.1 and 3.3.3, 3.3.5. These are the regularly asked questions. Okay. The intersection of any two subgroups of a group G is again a subgroup of G. This is the very important one. So if you know the definition of what is a subgroup, so on that you can solve the, you can do the proof of these theorems. So 3.3.6, 3.3.7, these are the regularly asked 10 marks question and also 5 marks questions. Okay. Next, in this most important topic is we have cyclic groups is there. So what is a cyclic group definition you should know, and you should know what is a generator in the cyclic group. This is the important one. So on cyclic group also 1 5 marks question you will get and 1 10 marks question compulsory you will get in the examination. So on this also you have many theorems are there. If you see this page number 60, we have every subgroup of a cyclic group is cyclic. This is the regularly asked repeated question. This will be asked for 10 marks question. And if you see the 62 page number 3.4.13, this is the problem you have for 5 marks question. So this is about the block 1. So block 1, we have the introduction of what is a group. When we call it as a group, so what are the conditions for a set to become a group? So that conditions, if you know, you can solve the problems and also theorems. Okay. And the third unit is about the subgroups, and we have the concept of the cyclic group. Okay. So this is about the block 1. If you see about the block 2, groups 2 we have, that is a group 1 we have, and this is a group 2. So in this we have the concept of cosets. So in cosets we'll have what is the same. Similarly, you need to know the definition of what is a right coset and what is a left coset will be there. So on this you have problems in your practical classes. So for finding the right cosets and the left cosets for a given problem. So if you know the concept of what is a coset, then you can know what is right and left coset. So one of the most important theorem in fourth unit is Lagrange's theorem for finite groups. Okay. This question will be asked for 10 marks question. So the question will be like this: state and prove the Lagrange's theorem for finite groups. Okay. So in unit 4, you have the definition of coset. What is a coset? And what is the definition of a right coset, and also what is a left coset. On this also you have problems are there. That is theorems. So in this, the most important theorem is Lagrange's theorem. Okay. And one more in 75 page number 4.3.7. This is the most important and regularly asked 10 marks theorem. Either you may get the Lagrange's theorem or this theorem. And 5 marks question is the 4.3.8. A group of prime order is cyclic. This is also a most important one. So this is about the fourth unit. So in fourth unit, you have 2 10 marks questions and 1 5 marks question. Okay. So if we go to the unit 5, this is about we have the what is a normal subgroup and also quotient groups. So here also the definition will be there. What is a normal subgroup and what is a quotient group? On normal subgroup, you have theorems, and on quotient group also you have theorems are there. So each and every topic compulsory definitions will be there. So 85 page number, you have 5.2.4, 5.2.5. These are the regularly asked questions, and even 86 page number, intersection and product of any two normal subgroups of a group G are again normal subgroups of G. So this is also most important one. 87 page number also 5.2.8. So next, you should know what is the quotient group also. Definition will be there. So through the definition, so question will be asked to define quotient group, and one theorem will be given. For that theorem, you have to write the proof. 95 page number 5.3.6. This is the most important one. Okay. The quotient group of a cyclic group is cyclic. Next, we have class equation is there. For this also you have the definition. So what is class equation? You have to know the definition. On this 5.4.5 theorem is there. No, this is asked for 5 marks question. And after this, you have the center of group is there. This is also the important one definition. On center of group also you have small theorem will be there. That is 5.4.7, 5.4.9. So class equation main 97 page number is there. 5.4.13. The class equation of a finite group. Okay. So definition will be asked, and also the theorem will be asked for this one. So this will be for 10 marks question. So this is about the 5th unit. Next we have the 6th unit, and this is the most important one. You have the homomorphism of groups. So similar concept, whatever you have the homomorphism is there of groups. In rings also, you will have the homomorphism of rings will be there. So here, you should know what is, if you know the definition of what is a group. So almost whatever the properties it is satisfying, similar properties will be there for to say that any given set is a ring. Okay. So almost similarities will be there for the group and also ring. So there also subring will be there. So quotient ring will be there, and homomorphism of rings and homomorphism of groups will be there. Okay. So one of the most important theorem in rings and also groups is the fundamental theorem of groups. Okay. Fundamental theorem of groups somewhat different will be there, that it is interlinked with the homomorphism definition. There also homomorphism of rings will be there. There also fundamental theorem of on rings will be there. Okay. So almost in the examination, whoever they will write, the students will confuse and they'll write for homomorphism of groups, they'll write the rings proof, and for the rings proof, they'll write the groups one. So compulsory in the question, it will be mentioned whether it is for the groups or it is for the rings. So you have to read the question and then you have to write the proof. Okay. So similarity will be there, somewhat proof. If you just see the differences between that, then you can solve the problem. So here we have the homomorphism definition is there. So in the homomorphism, we have definition is there. What is monomorphism? What is epimorphism? What is isomorphism? What is automorphism? Okay. So if you know the concept of the function, then we have studied one-to-one function, on-to function. Okay. So same similarly, if any function is there, if it is injective, then we call it a monomorphism. If a function is surjective, we call it as epimorphism. If a function is bijective, we call it a isomorphism. Okay. So function related, here the concept of homomorphism will be there. Homomorphism, in this you have theorems are there. 6.2.6 and 6.2.7. Okay, see in page number 107 you have 6.3.1. This is the most and regularly asked question. If you see the previous examination question papers, compulsory this question will be there. This is the fundamental theorem of homomorphism of groups. Okay, so you have to write even the statement also. The question will be state and prove the fundamental theorem of homomorphism of groups. Okay, you have to write the statement and you have to write the proof. Okay, 108 page number you have. This is the 10 marks question. That is a 10A or 10B question you will get. Next, one more important is the page number 112, 112. That is a 6.4.2. Cayley's theorem is there. So it is also important one. State and prove the Cayley's theorem will be asked. Next, we have permutation groups is there. Whatever the concept in intermediate you have studied about the permutations. So any given function will be given. So you have to find the permutation of that one. In that you have to find that is F circle G or G circle F, and also F inverse or G inverse. And also you have to find the disjoint cycles. So this is the one problematic, only one problem you have the chance of getting for 5 marks question in the section A from the permutations. So any function will be given. We have to find the cycle decomposition of the following permutation. You have 119 page number. So like this, any function will be given. You have to find F circle G or G circle F and also F inverse. In this only we have permutation concept. Disjoint cycles will be there and product of transpositions will be there. So this is only one question, which is the problem you will get for 5 marks question. Okay. So in this one theorem is also there. That is a 122 page number 122 page number 6.6.3. This is the theorem. It is also asked regularly. So sometimes it is asked for 10 marks question also. So these are the topics you have in groups. Okay. So whatever the definitions are there and also theorems are there in the groups. So similar definitions and also similar concepts will be there in the rings. So first we have the introduction of sets, relations and also functions. After that we have the introduction of groups. in groups, whatever the concepts are there, those are very important. If you understand the concept of the groups, then easily you can understand the rings. Okay. So next, if you go to the block 3, rings we have. So here also, when we call it as a ring, when we call it as a subring, you will have the definition will be there. 137 page number. There is a backside you have 138 page number. So when we call there only, you will have there is a with respect of addition or with respect of multiplication, we call the set as a group. Here triplet will be there, that is the R represents the real numbers. Here with respect of addition and with respect of multiplication. So that's why the triplet will write it as R of plus comma dot. So this is the main difference for groups and rings. Okay. So this triplet will be there. R plus, that is the addition we have. This star usually we use for the multiplication. Okay. So if you see the definition of the ring, a triplet R comma plus comma star is said to be a ring if R is non-empty set. Plus and star are two binary operations are satisfying the following axioms. First axiom is R comma plus is a commutative group. Okay. Next, R comma star is a semi-group. And third one is the star is distributive over addition. Okay, that means it has to satisfy the distributive properties, left hand distributive property and also right hand distributive property. If it is satisfied, then whatever the triplet is there, the triplet is called as a ring. Next, we have the concept of what is subring. Commutative ring will be there, ring with identity. So many definitions are there here. So, and which sets, that is natural numbers or integers or rational numbers or rational numbers or real numbers, which they are forming the rings. Whether here also same properties will be there: closure property, associative property, identity property, and also inverse property. Commutative property will be there and distributive properties will be there. If they are satisfying these all properties with respect of addition and also with respect of multiplication, then we got the set as a ring. Okay. So ring, for ring we have even matrices also. Okay. So even some matrices also they will satisfy under some conditions it form as a ring. So next we have subring. It is almost similar to, that is what we have seen subgroup. Now after that we have center of the ring is there, center of the group we have seen. No? So almost the same concept will be there, but the definition will be somewhat different. And 153 page number, you have one problem is there, 7.4.1. So this sometimes it is asked for 10 marks question. You have to show that whatever the relation is given, one of the on the set z of integer, define the operation plus and dot as follows. So this operation is defined as in two ways with respect of addition and also multiplication. Then we have to prove that z comma, that is triplet with respect of integers, is a commutative ring with identity. Okay. So here we have, see, first one is the commutative property, second one is the associative property, third one is the identity property, fourth one is the inverse property, fifth one is the, we have the distributive properties there. Okay. So if satisfy these all properties, then we call it as a semi-group. And with respect of even distributive laws are there, no? Identity property also, if it satisfies with respect of multiplication, then we call it as a commutative ring with identity. So while seeing the concept, we'll see these all. 7.4.5, this is also important theorem. And 157 page number, this is the 5 marks question you'll get. In this also we have the intersection of any two subrings. There we have to see intersection of any two subgroups will be there. Similarly, here intersection of subrings will be there. Next, if we go to the 8th unit, there we have seen the normal subgroup. That is the left coset and right coset we have seen. Cyclic groups. Here the topics will be somewhat different. That is unit 8 will be the integral domains and fields will be there. So what is a, when we call it as an integral domain and also when we call it as a field. These concepts are very important for means future, whatever the concept we are studying in other semester. So there we need the concept of what is a field. So zero divisors will be there. First main thing is you have to know what is integral domain. So division ring. So in this also many theorems are there which are very important for 5 marks question and also 10 marks question. So if we'll go for the unit 9, we have seen their ideals, no? There is a left coset and right coset we have seen, no? Same similarly, we have here instead of cosets, we have ideals will be there. So left ideal will be there, right ideal will be there. What is the main definition of ideal? Next quotient group is there, no? Here we have the quotient ring. So on this also, 184 page number 9.2.14. This is the 10 marks question you have. 9.2.15. Every field is a principal ideal ring. This is also 10 marks question. So these are the important. Next we have quotient ring definition and on that you have problems are there. 9.4.2, 9.4.3. These are the regularly asked questions. So from this only you will get the even 20 marks question. Next, if you go to the unit 10, in this, there is block 4, last block, rings 2. Similarly, concepts will be, here homomorphism concept will be there in the unit 10. That is homomorphism of groups is there, no? Here we have homomorphism of rings. In this, you have main important one problem is, that is theorem, fundamental theorem of homomorphism of rings. So the definition of homomorphism of groups and homomorphism of rings, there will be slight difference in the definition. So homomorphism of ring, here also endomorphism is there, automorphism is there, monomorphism, epimorphism, isomorphism. Same concept what we have in groups. So one more important concept in rings in homomorphism is kernel of a homomorphism of groups will be there and even for the kernel of homomorphism of rings will be there. You have the definition will be there. This is the image of F. IMF is there, no? It is called as image of F. So these are definitions you have to know. 206 page number, theorem 10.3.2. Next we have, so in this also many theorems are there. 210 page number 10.3.7. This is the 5 marks question. And even above one is there, no? 10.3.6, 3.6, 3.7, 3.8, 3.9. These are the regularly asked. And 212 page number, if you see 10.4, this is the fundamental theorem of homomorphism of rings. Just you can compare here what is the statement and proof for this one, for the groups and also for the rings. So somewhat difference will be there. There it depends on the homomorphism of groups definition and here homomorphism of rings definition. Okay. So this is the very important one. It will be asked for 10 marks question. It will be 11A or 11B question. Next, if we'll see the unit 11, it is a Euclidean domain and polynomial rings. So some up to unit 8, the same concepts you have for the groups and rings. From 9th and 10th, even 10th also you have homomorphism. It is also same, but some topics are different from the groups and also from the rings. So if you see unit 11, you have Euclidean domain and polynomial rings are there. Here also you should know what is the definition of Euclidean domain and when we call it as a polynomial ring. This whatever polynomial ring is there, on that you have one problem will be there which will be asked as the 8th question in the section A. So 2 problems you will get. One problem you may get from the permutation, and also one problem you will get on the polynomial of the rings. So only these 2 are the problems. Others are all theorems will be only there. 225 page number 11.3.11. So on this concept, you will have the problems. Next to 226 page number 11.3.12. This is the 20 marks question. That is a section C will be there, no? So in that 13 or 14th question, you will get this as a 20 marks. 11.3.12. Next to 229 page number 11.3.17. This is the determine the quotient and the remainder when f of x is divided by q of x. We have factor theorem is there, no? On factor theorem, we will have this problem. So this is for 5 marks question. 8th question will be asked. Next to 230 page number 11.4.2. This also you have the chance for getting 20 marks question. Next to 237 page number unique factorization domains is there. In this also we have one theorem which you will get for 20 marks question. So in this we have the definition of prime element is there, irreducible element is there. 239 page number 12.2.5. Given this theorem, main 20 marks theorem I have told now. 241 page number, it is the 12.3.2. This is very important in section C. You will get for 20 marks. 12.3.2. Next to 242 page number 12.3.4. This you will get for 5 marks question. Next, principal ideal domain and principal ideal ring. On this, we have some theorems are there. Okay. So these are the topics which we have in algebra. So first thing is, if you know the concept of the groups, so then easily you can do the theorems on rings. So, and one more thing is, if you want only the concept, your concept is only to pass the examination. So try to at least be perfect with only 2 blocks. That is the way. Either you do the groups or you do the only rings. That is, rings means 3rd and 4th block. If you are perfect, then easily you can score good marks. Okay. Or if you are perfect with 1st and 2nd block and each and every concept of group, if you are perfect, then you can solve how many means section A, you will have 5 marks questions, no? 4 5 marks questions you will get. So there you will get 20 marks. And here 20 marks in section B, 9th question and 10th question. Okay. So 20 means 40 marks. And here any 20 marks question you will get for the section C. So almost 60 marks you will get from any 2 blocks. So if you are perfect with any 2 blocks, why? Because this is the theoretical one. So compulsory, just we can tell the introduction of the concepts, whatever it is there. Theorems as you by heart question and answers. Similarly, you have to by heart them and you have to practice the theorems. You have to know statements of the theorems and all, some important theorems are there. No, Lagrange's theorem is there. There is a Cayley's theorem is there. Fundamental theorem is there. So which you need to even know the statements also. So statements will be asked and also proof you have to know. So compulsory statement you have to write and you have, with the help of the statement, you have to do the proof. So just as you by heart the question and answer, similarly these theorems, each and every line. If you know the definitions also, somewhat steps you can write there. So practice is main important for the algebra. And also the main definitions, if you know, and if you know how to write the steps in the proof, this is very important in doing the whatever the questions are there in algebra. So I have told only problems we are not there. Only 2 problems are there. That also, if you are luck, then the 2 problems will be asked. If it is also not asked, the theorems only will be asked in the examinations. Okay. So first today we'll start the unit 1. Unit 1 is about the concept of sets, relations and also functions. Okay. So before going to the topics of the groups and also rings, you need to know what we call it as a set and how we'll represent the set, because you will see some of the symbols and some of the representations in the groups and also rings. So if you know the concept of the unit 1, then easily you can see whether the given it is a function or given the concept is about the relations are there, or given any whatever the symbols are there. There you will see no notations. Capital N, it is represented for the set of natural numbers. If it is a Z, it is a set. We call it as a set. Why? Because set means it is a collection of well-defined objects. Okay. So in that, whatever the elements are there, those elements are well-defined, means they have the particular definition of that one. So if natural numbers means we know. So natural numbers will be starting from 1 and up to infinity will be there. And they are well-defined means 1, 2, 3, 4. So whatever the numbers are there, each have the some unique representation is there. So that's why a set we call it as a collection of well-defined objects. They are defined. They have some the definition of that one. So when you see those numbers, easily you can identify that these are the natural numbers. So when you see the integers means 0 will be the negative terms and also positive terms. By seeing that, it is well defined, means the definition, whatever the integers is there, with the help of that, it is represented. So that's why we have the concept. So this set representation of the numbers, we see groups and also rings. So that's why the first unit is very important and it is the basic foundation for all other topics in the block 2 and also block 3 and 4. Okay. So first one is sets, relations and also functions. So if you have textbook, once go through all the concepts of these topics, you have the definitions are there, and each and every topic is it is very briefly it is introduced with the help of the examples. So once you go through that, you can easily understand the concept of that one. Okay. So first unit about the sets, relations and also functions. Sets, relations and functions. Okay. First, we have the concept of what is a set. Set means it is a collection of well-defined objects. It is a collection of well-defined objects. Okay. We may call it as objects or even whatever the we'll write in the set, those are called as elements. Okay. Usually we represent the set with the help of the capital letters. That is any alphabet, with the help of the alphabets will represent the set. So standard notation will be there for the sum of the sets. That is if it is a natural numbers, we'll write it as a capital N. If it is integers, capital Z. C means complex numbers. And if it is Q means rational numbers. And it is Q complement, it is irrational numbers. Capital R is for real numbers. Okay. So this is for natural. These are the standard notation of sets. These are integers. So Z or capital I will write. Okay. Capital I, in some cases you may see even I also capital I. C is the complex numbers. Next Q is the rational numbers. Next Q complement is the irrational. R is for real numbers. So almost in third semester you have seen we have deal with only real numbers, that is capital R we have seen. So these whatever the standard notation of sets are, these are very important. These were how many 336 are there. These 6 sets will go through the all the units, that is from second unit to 12th unit. These concepts only will be there. That is whether natural numbers are satisfying the whatever the properties of groups are there, whether that is a set of natural numbers is a group, or whether it is a ring, or integers or complex numbers, or rational, irrational, or real numbers. Okay. So if you know the definition of different properties, with the help of that, if it is satisfied, then this may become group, or this like that, or this is a ring, or this is a it is not a ring, or not. If it is a ring means it has to satisfy some properties. If it is a group means it has to satisfy the properties. If whole whatever the properties it is satisfied, then we call set of natural numbers is a group, or set of natural numbers is a ring. Okay. So main concept will be from these standard notation of some sets. Okay. This is the set definition. It is a just normal definition to representation of the what is a set. So it is a collection of well-defined objects. You can write like this. Example, we can see one. So any set is there, you take it as capital A. Okay. So it is number of students in a class. Okay. So like this flower brackets you use. So number of students in a class means it is a well-defined. The definition is there. Number of students in a class means how many students are there in the class. You can count them and you can say what is the number of them. Okay. So it has the whatever the sentence is given in this bracket, it has some definition. Okay. So next, if you see intelligent students in a class. You're not taking the screen. So I'm writing here B is equals to intelligent students So if you have like this, any statement is given. So you can see there that first, whatever the set A, it is defined, it is a number of students in a class. So here, no doubt, you can know the number of students in a class. Okay. But here B, what it is given, set B, it has intelligent students in a class. We don't know how many intelligent students are there in a class. Means it is not well defined one. Why? Because the intelligence of the students may be, the percentage may be different. So by that we can't count them and we can say no. Easily by seeing them we can't. For that you have to conduct some of the tests and you have to see what is the percentage of intelligence of the students. So whatever this set is there, it is not well defined set. So therefore we can tell that it is not a set. The set should be compulsory some of the definition, that is a well defined objects will be there. So in that, so if here whatever the concept here written, it is the correct one. So A is the set here. Here, whatever the concept is there, here we can't find directly with the help of the, by seeing the students. So this concept we can't understand and we can't find. So therefore, B is not a set. So by this definition, compulsory set means it is a collection of well-defined objects, or what if you write the elements means, if you write the numbers, no, then we call them as the elements. Okay. Next we have the concept of subset is there. In sets only, we'll represent the set in two forms. So one form is the roster form is there, another form is the set builder form. So in problems or in theorems, representation of the sets will be there. So some will be in the form of roster form and some sets will be in the form of set builder form. So by seeing that, we can understand that whether they are given in which form. Okay. So set representation will be set representation is in two forms. Okay. First one is roster form. Next, second one is set builder form. So one question only we can write in two forms. So you can see the example here. A is equals to, the set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So a set we are writing it as a, that is the sum, we are writing the numbers up to 10. So some of the, that is a natural numbers we are writing from 1 to 10. Though this, whenever we are writing like this is called as a roster form. Okay. So usually some of the problems will represent as a set in the roster form, and in theorems will represent them in the set builder form. Okay. So we can write this in this second form also. That is A is equals to X, whatever this symbol is there, this is called as such that. Okay. Like this two dots will write semicolon, or else in some problems you will see like this slash will be given. This, either this representation or this representation, both are same. This is called as such that, and even this is also called as such that. So in some problems or in some sets, they will write this or they will write this symbol. Both are same. So don't get confusion there. So X such that X belongs to, these all whatever the numbers are there, they belongs to natural numbers, and what are they? Those are X is less than or equals to 10. Same, no? This is the roster form. Just you have whatever the set builder form is there, this expansion you are writing here. That is X such that X is the whatever the elements are there in that, you are taking it as X. These belongs to numbers, belongs to natural numbers, and they are, how many numbers you are taking, those numbers are less than or equals to 10. Less than means up till 9 only. But we have even 10, no? Therefore, we are writing the symbol as equals to. So, this representation of this roster form in such a way, it is called as a set builder form. Okay. Any numbers you can take. Either even numbers, that is 2, 4, 6, 8, 10 you can write. And here you can write X such that X belongs to N, and X is, that is X such that X belongs to natural numbers. X is the even integers, even numbers. Okay. So which are less than or equals to 10. So representation of the, if you expand this one from here, whatever you are expanding this is the roster form. And if you are writing the whatever the meaning is there here, you are writing in this form, it is called as a set builder form. So these two forms are important for solving the theorems. Next we have types of sets are there. So this concept also very important. So representation of these sets will be there. So usually in theorems, we'll see these type of sets. So first one, the main important one is we call it as empty set. Okay. Or we call it as null set. So if a set is having no elements, that is zero elements, then we call it as a empty set. Okay. A set without the elements is called as an empty set. So we'll represent it as, it is a pi. Okay. So pi is the symbol and we will write it as a set means like this. Set pi means no elements. Okay. First one is the empty set or null set. Next one is the singleton set. Or we call it as unit set. Okay. Unit set or singleton means only one element. So that set is called as a singleton set. A you can write R1 or anything. Okay. So next third one is the finite set. Finite set means whatever the set is there, if it has finite number of elements in it, then we call that set as a finite set. Okay. You can represent like this. Set A is equals to 1, 2, 3 up till 10. Okay. In this, we can count the elements. Elements can be counted. Okay. Next, we have infinite set. Infinite set means in which elements cannot be counted. Okay. We can take example, set A is equals to stars in galaxy. We can't count them, no? So this is the infinite set in which elements cannot be counted. Cannot be counted. Okay. Next we have equal sets. Equal set. Number of elements and elements are same. Fifth one. Equal set. Equal set means in this number of elements. Number means count here. Okay. Number of elements and elements are same. Okay, this is the definition here. Number of elements means if there are 4, means the element in another set also you should have the 4 elements and those elements 4 should be same. Okay, you can take the example here like this. Example, if A equals to 1, 2, 3, 4, then B should be also equals to 1, 2, 3, 4. Then we call A is equals to B. So this is the definition of equal set. Okay. Next we have, you are able to see now one more. Equivalent set. Equivalent set. Okay. Here number of elements in A, set A should be equals to number of elements in set B. Okay. Equivalent set means number of elements in A should be equals to number of elements in B. Equal set means what? Number of elements should be equal and whatever the elements are there, those elements should be same. But here equivalent means just the number. Elements may be different, but only the number, if they are same, then we call it as a equivalent set. Okay. Number of elements same. Number of elements are same, but elements are different. Okay, you can take example here. A is equals to A comma B comma C comma D. Here how many number? N of A is what? 4. Okay, number of elements C is equals to 4 here. Next, if you take B, 1, 2, 3, 4. So here N of B is what? 4. Irrespective of the elements, we are taking just the number of elements. N of A equals to N of B. So therefore, what we have, N of A is equals to N of B. So therefore, it is a equivalent set. So like this, we have different types of sets are there, which will go through even theorems, and also there is in groups and also in rings, or even in further higher education also. You will, if you know the concept of these, then easily you can solve those theorems and also problems. So you should know these all definitions. What empty set regularly will come through this one. Empty set or null set. Next, singleton test set will be there. Finite and infinite, these two are very important. These two concepts rarely in some theorems you may have. Okay. So this is the sets, types of sets we have studied. What is the definition of set we have studied? And one more main important topic is the subset. So subset for theorems, even if you know the concept of the subset, then easily you can understand the concept of subgroup and also subring. Okay. So those, just if you know, already we know what is a set. Subset means, here set means only representation of one set we are taking. When we say sub, means from whatever the set we are taking, any set A is there, from that in any set B. Set A, you think 1, 2, 3, 4 elements are there. If you take the set B, in that 1, 2, 3, 4, 5, 6, including of set A and extra some elements will be there. Even in some case, same elements will be there. Then we call it as equal set. When same elements are there means equal set. So whenever in set A, whatever the elements are there, instead of that, some addition of some more elements will be there. So then we call set A as a subset of set B. Here set B we have 6 elements, and here set A we have 4 elements. Those 4 elements are included in set B. Then we call set A here. Set A, why? Because in set A only 4 elements are there. If both are same means, then we can write A is subset of B, B is subset of A. Okay. Just we see the definition of that one. Subset. Okay. So direct what is subset, we don't have the definition. So we can tell that if set A, that is if A and B be two sets such that every element, see here, every element of A is an element of B. Okay, this is the main important here. Such that every element of A is an element of B. So if here in set A 4 elements are there, compulsory those 4 elements should be there in set B. So then we call A is subset of B. Okay. Then we say that then we say that A is a subset of B. Okay, and we denote it as or we write it as, you can write anything. Like this, A is subset or equals to B. Okay, A is subset or equals to B. So this is the subset definition. So you can take example like this. Example, A is equals to 1, 3, 5. Okay. So if A is any set and B is equals to 1, 2, 3, 4, 5, 6. Okay. So if A is equals to 1, 3, 5. So we have here no in B 1, 3, 5. So A is subset of B. A is subset of equals to B. Here not equals to. Why? Because other than these 1, 3, 5, you have other elements are there. Okay. So then we'll write it as A is subset of B. So if same elements are there like this, A equals to 1, 3, 5 and also B is equals to 1, 3, 5. So then we can write A is subset or equals to B, or else we can write A is equals to B. That is the equal set, we have the definition. So that we can write. So A is, so whatever the elements are there in A, those elements should be there in B. Equal elements may be there, or else other than this, you may have other elements also. Then we call it as A is subset of B. So if A is not subset of B means, we'll represent it as if A is not a, the symbol also you see in some theorems, is not subset of B, we write as A is not, like this. Okay. Cross symbol if it is there means it is not subset of B. If it is there like this means it does not belongs to. I hope you know this symbol. It is the belongs to symbol. So if cross mark is there means it does not belongs to A, does not belongs to B. Here A is not subset of B. Okay. So if any set is given, so how we can write the subsets? If any set is there, A is equals to A comma B comma C. Okay. Write subset for this one. So you can write many different types as means different types you can write this set A as subsets. So first one is only single term, that is set A, set B. This is also subset. No, A is subset of this one, B is subset of this one. Next C is subset of this one. Next we can write A into B. Okay. Next B comma C. Next we can write RAC. Okay. Next the set itself we can write A comma B comma C. So like this way, first thing is compulsory pi. Okay. So pi is the empty set. Here you can write one important note that empty set is a subset of every set. Here you can write the note. This is a very important one. Empty set is subset of every set. Okay. So that's why if in any problem it is asked to write the subsets of the given set, then compulsory first one will be the pi. That first empty set will be there. After that, all the singleton sets. So you can see this one, page number 5, you have example is there, see, 1.2.5. Okay, A set is there. Further, you are writing the all the sets. Like this, you can represent this one up to here. So these are all the subsets of the A. Okay, in next class, we'll see the other concept of this one.